Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam LTAM. This is problem number 2 from written answer section from the last exam LTAM. An insurer issues a whole life insurance of $50,000, or 50,000, we don't know the currency, but anyway, to a 55-year-old with a waiver of premium and disability. You are evaluating this policy using the following model. As you can see, the person can go from active state, which is state 0, to being disabled or to being dead. Once a person becomes disabled, that person can only go into state 2 of being dead, and state 2 of being dead is absorbing. You are giving that gross premium G is paid at the start of each year if the insured is active. 2. The death benefit is payable at the end of the month of death. 3. Commissions are 5% of each premium paid. There are no other expenses. 4. Interest rate for valuation is 5%, and notice that 5% is the interest rate used in the standard ultimate life table used on the exam. You can find the table at smarturl.it/SULT. Next, we're also given the values of certain actuarial present values of certain actuarial functions, and for age 55 and 65. And the first one is payable monthly, a form of life insurance that pays if you transition from state 0 to state 2, the actual present value of that. So it's a bit strange because you have this 1, 2, and then 0, 2. But that simply means 12 in parentheses means that the payment is at the end of the month of death, and 0, 2 means that the payment is upon transition from state 0 to state 2. And same for transition from state 1 to state 2. State 2 is being dead, and it's an absorbing state. And you also have the actuarial present value of a life annuity payable as long as life in state 0 at the beginning remains in state 0. Notice that there are no returns to state 0, so this is pretty straightforward in terms of how this annuity works. As long as the person remains active, the annuity continues, and this is the annuity that describes how the premiums are paid. Then 0L upper G denotes the present value of the gross loss at issue random variable. TV upper J denotes the gross premium reserve at time T for a life that then in state J. Question A, part A of the question. The gross premium is determined such that E of 0LG, so the loss at issue expected value, for gross premium, so including gross premium and expenses, is minus 0.1 G. So the expected value for loss is negative, which means that there are profits. Show that G is equal to 2900 to the nearest 100. You should calculate G to the nearest 1. Part B, question, show that reserve for state 0 at time 10 is 16,800 to the nearest 100. You should calculate the reserve to the nearest 1. Then you are also given that a reserve at time 10 and 1/12, so 1 month after time 10, for state 1 is 34,110, and reserve for time 10 and 2/12, so 2 months after time 10, for being in state 1 is 34,170. We also given the following probabilities for age 65 and 65 and 1/12 of transition from state 0 to state 1 within 1 month, so 1/12 of a year, and for transition from state 0 to state 2 within 1 month, and for transition from state 1 to state 2 within 1 month. Part C, or question C, part 1, show that reserve for state 0 at time 10 and 1/12, so 1 month after time 10, is 19,500 to the nearest 100. You should calculate the value to the nearest 1. And part 2, calculate 10 and 2/12 time reserve for state 0, so 1 month later than for part 1. Now part D of this question, to increase sales, the insurance company raises its commission rate to 15% of the first premium and 8% of each renewal premium paid. The gross premium is not changed. Without a further calculation, state with reasons whether the value of reserve at time 10 and 2/12 for state 0 will increase, decrease, or stay the same as a result of these changes. And part 2, without further calculation, state with reasons whether the value of 10 and 2/12 of reserve for being in state 1 will increase, decrease, or stay the same as a result of these changes. Here's the solution. For part A, we have, with EPV standing for expected present value, minus 0.1 G equal to the expected value of prospective loss at issue, including gross premium and expenses, which is the expected present value of death benefit minus present value of premiums net of expenses. And it's really expected present value that I should have said there for premiums net of expenses. My apologies. So it should be EPV in both cases. That's equal to 50,000 A55 upper 1202 minus 0.95 times G A double dot 5500, which is 50,000 times 0.48 minus 0.95 times G times 8.832, and that becomes 24,000 minus 8.3904 G. Now we have those actuarial present values given in the problem, so that's what we did. We just plugged them in. And this is an equation in which G is the unknown. We solve it, and we obtain the result that G is approximately 2,894.91. For part B, we calculate 10V0, so reserve at time 10 for being in state 0. That's 50,000 A65 upper 1202. That's the actual present value of future benefits, or expected present value of future benefits, minus 0.95 GA double dot 6500. That's the expected present value of future premiums net of expenses. That's 50,000 times 0.634 minus 0.95 times 2,894.91 times 5.416. That's from the calculation of the premium, how we know that's 2,894.91. We just calculated it. And the other numbers are given in the problem. And this is approximately 16,805.09. For part C, part 1, we calculate 10 and 1/12 time reserve for state 0 using the recursive reserve formula. So reserve in state 0 at the beginning of the year plus the premium which is 0.95G after expenses, accumulated with interest pays for those who survive in state 0 for the reserve in that state, for those who transition to state 1 with probability 112p6501 for the reserve in state 1, plus they pay for those who transition to state 2, so they die, $50,000 of death benefit. Note that 112p6500 is 1 minus 112p6501 minus 112p6502, because the probabilities of all transitions have to add up to 1, and that's approximately 0.99246. So we just plug in all the numbers that we know and solve for 10 and 112 V0, V upper 0, for the reserve in state 0. So after we plug in all the numbers, and we actually solve for that reserve first, then plug in all the numbers, and we obtain approximately 19,478.06. For the second part, we calculate 10 and 2/12 time reserve for state 0, again using the recursive reserve formula, but starting from time 10 and 112. The reserve at that time, accumulated with interest, pays for the reserve in state 0 if the person remains in state 0 with probability of remaining in that state, plus a reserve in state 1 if the person remains in that state, multiplied by the probability of being in that state, plus probability of transitioning to state 2, death, times the death benefit. And here the unknown is 10 and 2/12 V upper 0. We solve for it, and then we plug in all the numbers because we have all of them, except the bottom one, 112p 65 and 11200. That needs to be calculated as 1 minus the two probabilities of transition from state 0 to state 1 and transition from state 0 to state 2. So after we plug in all the numbers, do the calculation, we get approximately 19,398.16. Now part D, the first part. So we're doing part D right now, the last part of the question. For the first part, the reserve for state 0 at time 10 and 2/12 is equal to the expected present value of benefits minus expected present value of future premiums net of commission. Of course, it's the future benefits that we put in here. And the expected present value of benefits is not affected by the change in commissions, but the expected present value of future premiums net of commissions, my apologies, net of commissions will decrease. And therefore, because the commissions are increased and the premium is unchanged. Therefore, the reserve will increase. For the second part, again, it's the same type of a formula, but now for being in state 1. And the expected present value of benefits is not affected by the change in commissions. Since premiums are waived while in state 1, no commissions are paid. No transition back to state 0 is possible from state 1. Remember, that was what we noticed at the beginning. Hence, change in commissions will have no impact on the expected present value of future premiums net of commissions. Thus, the higher commissions will have no impact on this reserve. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.